So in the previous video, we had gone over a list of common derivatives that is necessary in order to pass any calculus course. And in today's video, we will start to apply that long list of derivatives by introducing the concept of the product rule, which is essentially the rule that you're going to need in order to take the derivative of any product of two functions. Say we're given the function right over here, which is f of x is equal to 3x times sine of x. Unlike the limit laws, you cannot take the derivative of a function of a product of two functions, rather simply by taking the derivative of each of them. The derivative of the product is not the product of the derivatives. So if you went and said that f prime of x for this function was 3 cosine of x, that would be wrong. You cannot take the derivative using that method. So we're going to be using a concept called the product rule. I'm not going to prove it in this video, however, I will give you the formula in order to take the derivatives of products, and we'll go through a couple of practice problems in order to get a feel for how the product rule works. So if you want to take the derivative of a product, so we will write this down as d by dx of f of x times g of x, where f of x and g of x are two different functions, it will be equal to f prime of x multiplied by g of x plus f of x times g prime of x. So essentially what it is that I like to do in order to take the derivatives of products is I like to write a list of all of the functions that are currently present and take each of their derivatives and plug them into this formula. Now it doesn't make sense right now, it will in just a second. Say we wanted to take the derivative of this function, 3x times sine of x. So we can split this up into two functions which are easily differentiable. So 3x, we know we can take the derivative relatively easily, and sine of x we can also take the derivative of relatively easily. So we will split this up into an f and a g. So our f of x will be 3x, and our g of x will be sine of x. Now we know that we can take these functions and differentiate them easily, so we'll do exactly that. So our f prime of x, which is the derivative of our initial function, or our initial f, is 3, and then our g prime of x is the derivative of our g, which is cosine of x. Now in order to take the derivative of this function, all you need to do is plug them into this formula right over here. So you're going to have f prime multiplied by g, and then you're going to add on f times g prime. So if we wanted to take the derivative of this function, we would cross this with this, and then add on this multiplied by this. So essentially what we'll be left with is 3 multiplied by sine of x, and then we will add 3x multiplied by cosine of x. If we wanted to clean this up slightly, we can pull out a 3. So this would be 3 multiplied by sine of x plus x cosine of x. And that is the derivative of our initial function, 3x sine of x. So now we'll just go through a couple, or rather a handful of examples of how to apply the product rule. It's always the same process. You just write out your f, your g, your f prime, and your g prime, you connect them, and then you add them all up. So say we wanted to take the derivative of the function 3x squared times cosine of x. Now once again, what we'll be doing is splitting this up into two functions that are very easily differentiable. We know how to take the derivatives of them easily. So we know how to take the derivative of 3x squared using the power rule that was discussed a couple videos ago. And we know the derivative of cosine of x using both the limit definition of the derivative, it was released in a couple of videos ago, how to take the derivative of cosine of x using the limit definition, or in the previous video that I just released with all of the trigonometric, inverse trigonometric, and logarithmic derivatives. So we know both of these derivatives here. So our f of x, let's just go and erase this. So we will write this out as our f of x will be 3x squared. Our g of x will be our second function, which is cosine of x. And now we want to differentiate each of these functions. So the derivative of 3x squared is 6x using the power rule, and the derivative of cosine of x is negative sine of x. Now it's just a matter of joining f prime with g and f with g prime, multiplying them out and then adding them up. So we will have f prime times g will be 6x times cosine of x, and then we will add on 3x squared times negative sine of x. 3x squared times negative sine of x. Because this will end up being a negative, we can simply kill this positive and make it a negative instead. So we'll be left with 6x cosine of x minus 3x squared sine of x. If we wanted to clean it up a little bit further, we can do a little bit of factoring here. So we can pull out a 3x, and we will be left with 2 cosine of x minus x times sine of x. However, most of the time your teachers are not going to expect you to factor it out, but if you really did want to clean it up, factoring is the way to go. So let me just take a moment to write a couple of steps that are necessary in order to take the derivative of any product. So these are pretty much the 2 steps that you need to follow every single time you want to apply the product rule and take the derivative of a product of 2 functions. Just write out a list of all of the functions that are present, the 2 easily differentiable functions, which are f of x and g of x. Write out their respective derivatives using either the power rule or from the list of derivatives that we had covered in the previous video. And essentially what it is that you can do after that is you're going to join up your f prime with your g and your f with your g prime, and you will add them up. That is the entire idea behind using the product rule. That's how you can take the derivative of any product of 2 functions. So we will move on with a couple more examples, rather a handful more examples. Say we have the function, we want to take the derivative of sine squared of x. Now up until now I've always been using the chain rule in order to take the derivative of sine squared of x. However, the product rule also works because essentially what it is that you can do for this function is you can split it up into a product of sines, because sine of x multiplied by sine of x is also sine squared of x. So we can write this out as y is equal to sine of x times sine of x. Now step 1, we want to define what our f and our g are going to be. So our f of x will be sine of x, and our g of x will also be sine of x. Now we just need to take the derivative of each of these. So we'll be left with f prime of x is cosine of x. Same thing for the g prime of x. And then we join all of these together, so we'll have f prime multiplied by g and g prime times f, and then we will add them up. So f prime times g will be sine of x times cosine of x, and then we will add on f of x times g prime of x, which is also sine of x times cosine of x. And because these are the exact same thing repeated twice, we can just join them together and tack on a 2. So this is equal to 2 sine x cosine of x. And if you really want to impress your teacher, you can also fit this into a trigonometric identity. This is exactly the same thing as sine of 2x. Totally unnecessary, but if you really wanted to freak your teacher out, a lot of people are not familiar with trigonometric identities. So either this or this are a suitable answer for this question. So say we wanted to take the derivative of the function 7x to the third times cosecant of x. Essentially what it is that we're doing is we're splitting this up into 2 easily differentiable functions. We can split this up into 7x to the third and cosecant of x, both of which should be very easy for us at this point if we familiarized ourselves with the list of derivatives that was covered in the previous video. So our f of x is 7x to the third, our g of x is cosecant of x, and the derivative of our f of x, so f prime of x, is going to be drag the power down and then subtract by 1, so this will be 21x squared, and then g prime of x will be negative cosecant of x times cotangent of x. Now it's just a matter of joining things together and then adding them up. So we multiply f prime times g and f times g prime, and we add it all up. So this will become 21x squared. 21x squared multiplied by cosecant of x. And then we add on whatever is left over here, which is going to be 7x to the third. Let's open our brackets over here, multiplied by negative cosecant of x times cotangent of x. Now we can pull the negative sign out and kill this positive right over here. So this will leave us with 21x squared cosecant of x minus 7x to the third cosecant of x cotangent of x. If you wanted to clean it up a little bit further, you can also do some factoring. So here, what I see we can factor out is a 7x squared and a cosecant of x. So if we factored out a 7x squared, essentially what it is that we would be left with is 3 minus 7x to the... Okay, so we'll be left with x times cotangent of x. Assuming that I did that properly, that should be the derivative of our initial function. Next example. Oh no, I erased all my f's and g's. Alright, I'll restart. So we want to take the derivative of the function arc sine of x times e to the x. Arc sine of x times e to the x. So we will define our two easily differentiable functions and then take each of their derivatives. So our f of x, g of x, f prime of x, and g prime of x. Another little note that I'd like to make on the product rule: the order in which you choose your functions to be differentiable, whether you make this your f or whether you make this your f, whether you make this your g or this your g, does not matter when it comes to the product rule because it's an addition anyway. However, when it comes to the quotient rule and you will need to perform a subtraction, it will matter which one is defined as your f and your g. So it doesn't matter in the product rule. So we will define arc sine of x to be our f of x. And we will define e to the x to be our g of x. Now, just as I had discussed in the previous video with the list of all of the long derivatives, the derivative of arc sine of x is 1 over the square root of 1 minus x squared, and the derivative of e to the x is e to the x. Now it's just a matter of joining things together, so e to the x times 1 over the square root of this whole mess. So we join f prime with g, and we join f with g prime, and then we multiply them out and add them up. So we'll have f prime times g, which will be e to the x times 1 over the square root of 1 minus x squared, and then we will add on arc sine of x times e to the x, which is our f times our g prime. If we want to clean this up a little bit, we can just throw this into the numerator. So this will be e to the x over the square root of 1 minus x squared plus arc sine of x times e to the x. Clean it up a little further, we can factor in e to the x out. So all we'll be left with is 1 over the square root of 1 minus x squared plus arc sine of x. And that is the derivative of our initial function. So we want, actually let's clean this up. We know at this point how the formula works. Say we wanted to take the derivative of x times ln of x. We can split this up into two easily differentiable functions. So this will be our f and this will be our g, or vice versa, whatever it is that you'd like. So our f of x is x and our g of x is ln of x. Now the derivative of x is simply 1. You can view this as 1x, so all you really need to do is take away the x and your derivative will be 1. And the derivative of ln of x, as we had covered in the previous video, is 1 over x. So now we just need to join these together and then add them up. So f prime of x times g of x will simply be 1 times ln of x, that's just ln of x. So this will leave us with ln of x, and then we will add on x times 1 over x. So x times 1 over x, the x's will cancel each other out, and all you'll be left with is 1. So the derivative of our initial function is ln of x plus 1. Very simple. Product rule is very easy to use. Next up, we want to take the derivative of log base 5 of x, log base 5 of x times secant of x. So now we'll split this up into our two differentiable functions, our f and our g. So our first function will be log base 5 of x, which was discussed in the previous video of all of the common derivatives, where it is that the derivative of log base a of x will be equal to 1 over x times log of a. So the derivative of log base 5, actually let's just write this down first. Our f of x will be log base 5 of x, and our g of x will be secant of x. And then using this, we know that the derivative of log base 5 of x will be 1 over x times log of 5. And then our g prime of x is the derivative of secant of x, which is secant of x times tangent of x. Now we just join things together and add them up. So we will be left with secant of x times 1 over x log of 5, x log of 5, and then we will add on log base 5 of x times secant of x times tangent of x. So this will be log base 5 of x times secant x tangent x. Now we can drag this into the numerator. This will leave us with secant of x over x log base 5 of x, log base 5 I mean, log of 5, plus log base 5 of x times secant x tangent of x. If we wanted to do some factoring or cleaning things up, we can factor a secant of x out of the numerator here and the numerator here. So we will be left with 1 over x log of 5 plus log base 5 of x times tangent of x. And that is our fully simplified derivative. A couple more examples and we'll be done for today. We want to take the derivative of 5 to the x times arctangent of x. So 5 to the power of x multiplied by arctangent of x. These are two easily differentiable functions using all of the derivatives that we had covered in the previous video. We know that the derivative of, actually let's write these out first. So our f of x will be 5 to the x and our g of x will be arctangent of x. And we know from the previous video that the derivative of any constant raised to the power of x, so d by dx of a to the x, is simply a to the x multiplied by the natural logarithm of a. So the derivative of 5 to the x is 5 to the x times ln of 5. And then, just as we covered in the previous video, the derivative of arctangent of x is 1 over x squared plus 1. Now we just join things together, our f prime with our g and our f with our g prime. So we will have 5x ln of x, 5 to the x ln of x, 5 to the x times ln of 5, times arctangent of x, plus 5 to the x times 1 over x squared plus 1. So we can just join these together, put this on the numerator, and this will be what's left over in the denominator. So this will be 5 to the x over x squared plus 1. And what we can do here is factor out a 5 to the x. So we'll be left with 5 to the x times ln of 5 times arctangent of x plus 1 over x squared plus 1. Might as well be consistent with the types of brackets that I use. 5 to the x times ln of 5 arctangent of x plus 1 over x squared plus 1. That is the derivative of our initial function. Last two and we will be done for the day. We want to take the derivative of log base 2 of x times ln of x. Now we're already familiar from the previous example how to take the derivative of a log with a base of a, whatever it may be. So we will split this up into our initial functions, which is log base 2 of x and ln of x. Both of these functions are easily differentiable if you familiarize yourself with the list I had just released. So f of x will be log base 2 of x, and the g of x will be ln of x. Now our f prime of x is the derivative of log base 2 of x, which is 1 over x times log of 2, and the derivative of ln of x is 1 over x. So we will join our f primes and our g, and our f with our g prime, and then add it all up. So we will be left with f prime times g, which is ln of x over x times log of 2. And then we will add on log base 2 of x times 1 over x. So that's just log base 2 of x over x. So log base 2 of x over x. If you wanted to, you could factor an x out of the denominator to simplify things. However, this is fine the way it is. If you wanted to factor out, you would have 1 over x out here, and then you would have ln of x over log of 2 plus log base 2 of x. That is our full derivative. And then we will move on to our final example for today, and this will wrap up the idea of the product rule. These are all some pretty simple examples for product rules. Once we've learned the quotient rule and the chain rule, we'll move on to some more complex products. However, for now, this is just getting a feel for how the product rule works. So our final example for today will be the derivative of secant of x times tangent of x. Which is also the derivative of secant of x. So we want to split this up into two easily differentiable functions, which is secant of x and tangent of x. So our f will be secant of x, and our g will be tangent of x. Aspetta, nonna! Sorry about that, got interrupted for a second. We want to take the derivative of secant of x times tangent of x. We have defined our f to be secant and our g of x to be tangent. So we want to split this up into our two and then take their respective derivatives. The derivative of secant of x will be secant of x times tangent of x. And the derivative of tangent of x is secant squared of x. So we will join our f prime with our g and our f with our g prime, and we'll be left with f prime times g of x, which is secant of x tangent of x times tangent of x. And then we will add on secant of x times secant squared of x. So if we wanted to join all of our like terms and multiply everything out, what we would be left with is secant of x times tangent squared of x. And then we add on, join these two together, secant cubed of x, simply by adding the exponents. Now if you wanted to clean this up a little bit, we would be left with, we could factor a secant of x out, and we would be left with tangent squared of x plus secant squared of x, sorry about that. And that is our final derivative. So that's pretty much it that I wanted to cover in this video. Remember that this was just an introduction to the concept of the product rule. I will be covering some more complex products once we know how to use the quotient rule and the chain rule. However, for now, this was just an introduction to the feel of the product rule. Afterwards, things will get slightly more complex when it comes to taking the products of composition functions and whatnot. However, if you have not familiarized yourself with the list of derivatives that I have released in the previous videos, in the previous video that I had just released a couple days ago, you can either familiarize yourself by watching that video, or if you haven't already, check out the document that I have written up. It's on my website. I will post a link to the document in the comments below, and I will see you guys in the next video.